Kirchoff's law experiment. First you need to set up this circuit. You're on your own. What I do is try to follow the circuit. Here's the E1 in your circuit diagram. I start at the positive there. A wire has to go over into resistor number 1, labeled on the board, out of resistor number 1, over into resistor number 3. You'll see that this is set up quite easily. There are white lines on the board to show you where the wires go. So after you get the circuit set up, you want to set these voltages. So I have here a multimeter, and I've got it on V with the two little bars on top. That's DC voltage. And then I want to go across the first power supply from plus to minus. And this should be set at 12 volts. You'll see that the multimeter is reading negative 11.9. The negative, positive is immaterial. You can always just switch the wires around and change the sign from one to the other. So we just ignore it. So it's 11.9. I want to adjust it to 12, so I turn it up a little bit. 11.99, 12.0. So I do that. I set these other power supplies at the voltages they should be. Now my goal is to measure what I want to measure and write down are the currents flowing through each of these resistors. So current number 1, which we call I1, I need to break the circuit and let the current, this is now a current meter, it's set at 400 milliamps. 400 milliamps with two little bars on top, meaning DC, not AC. So I need to break the circuit. I'm going to break the circuit where it goes into resistor number 1. I'm going to put that into the meter, in the milliamp input. Then I'm going to take the output of the meter and plug it into where I broke the circuit. So now I've got the current that's flowing. I've got the current that's flowing through R1 flowing through the current meter. And I read 76.5 milliamps for R1. If you come between 75 and 80 milliamps for R1, it indicates that you probably have the circuit hooked up correctly. So now I remove the meter and replace the wire back into R1, putting the circuit back to where it was. Now, for instance, I would go to R2, which is over here. I break the circuit, either coming in or going, the same amount of currents flowing into R2 is flowing out. So it doesn't matter where I break the circuit. I put it into the meter, then I take the output of the meter and put it in to where I took out the, where I broke the circuit. And I'm reading 68.3 milliamps. I'd write that down, then put my circuit back, take the meter out and put my circuit back together, and so on until you measure the current through each of the resistors. Record all those currents, and you're done.